Let us do gravity and gravitation. Now, before doing gravity and gravitation, let us give us a brief introduction. Now, we know that there are four fundamental forces in nature. There are four fundamental forces in nature. What are those forces? Those forces are: number one, strong force. Strong force. Now, number two is electromagnetic force. Electromagnetic force. And number three is your weak force. Weak force. Number four is gravitational force. Gravitational force. So fundamentally there are four forces in nature. These forces are strong force, electromagnetic force, weak force, and gravitational force. Now, the electromagnetic force is a combination of electric and magnetic force. This is combination of electric and magnetic force. The nuclear force or the strong force holds between protons and neutrons together inside the nucleus. The weak force is between any two. The weak force is between any two elementary particles. And your gravitational force is between any two bodies having masses in nature. Any two bodies having masses will experience gravitational force of attraction. Now, the relative magnitude of the four forces are, say this is 1. This electromagnetic force is 10 to the power of minus 2, and this weak force is 10 to the power of minus 13, and gravitational force is the weakest. It is 10 to the power of minus 38. So what are these? These are relative magnitude of four forces. Relative magnitude of four forces: strong force 1, electromagnetic force 10 to the power minus 2, weak force 10 to the power minus 13, and gravitational force is 10 to the power minus 38. You see, it is very 10 to the power minus 38. It is the weakest force in nature, but it controls the structure and the evolution of the universe and influences every action of our everyday life. So everyday life everywhere we experience gravitational force of attraction. So gravitational force of attraction is between any two particles. It is between the sun and the earth, okay, and it is between any bodies having masses. So today we will explain gravity and gravitational, or gravity and gravitation, or that is the work done by the gravitational force. Now, first of all, we all know that Newton discovered the laws of gravitation. So let us now study universal laws of gravitation. Laws of gravitation. So let us study universal laws of gravitation. Now, as you know, this laws of gravitation was discovered by Isaac Newton in 16666. So remember, 16666, 3 sixes. So it was discovered by Isaac Newton in 1666. Now, in this regard, what happened? According to his law, everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So suppose you have two masses. So one mass is, say, capital M, and one mass is small m. Now the distance between the forces is, say, r. So according to Newton's laws of gravitation, the force of attraction is proportional to the product of their masses. So the product of their masses is F proportional to capital M small m, and the force is inversely proportional to the square of the distance between them. So F proportional to 1 by r squared. Now if you combine these two, what we get, that F is equal to some constant g into capital M small m divided by r squared. So as you have learned in school, what is this g? This G is called the universal gravitational constant. It's called the universal gravitational constant. Now, why it is called universal gravitational constant? Because the value of G does not depend upon the intervening medium. Means whatever may be the medium, the value of G remains same. That means these two bodies may be in air or water or in vacuum. The value of G is constant. So the value of G does not depend upon intervening medium. It also remains unaffected by temperature. So the value of G is unaffected by the presence of or under the effect of any temperature. Further, the laws of gravitation does not depend on the nature of attracting masses. So what if this may be a stone and this may be a sand, so this may be earth, this may be a sun, or this may be a solid object, this may be a water. So it does not depend upon the nature of attracting masses. So sometime a question may be asked, why G is called universal laws of gravitation? The G is called universal law of gravitation because number one, it is not affected, or it does not depends upon intervening medium. Intervening medium. Intervening medium. MEDIUM. Okay, so it does not depend upon the intervening medium. Number two, it does not depend upon the temperature. So it is unaffected by the presence of any temperature. It may be -0 or minus degree some centigrade, -50, or it may be 0, or it may be plus 50. So it is unaffected. The value of G remains unaffected with temperature. And number three, the value of G does not depend upon the nature of the attracting masses. So whatever may be the nature of the attracting masses, the value of G remains constant. Now what we can do is we can define G. How to define G? What we can do is we can make capital M is equal to small m is equal to 1 unit, and we can also make R is equals to 1 unit. So we can, if you place capital M equal to small m equal to 1 and R equals to 1, then what we get is we get F equal to G. So from here we can define the value of G. The gravitational constant is defined as the force of attraction between two bodies of mass, it may be 1 kg or 1 gram or 1 unit, separated by a distance of 1 meter or 1 centimeter or 1 unit. So gravitational constant is defined as the force of attraction between two bodies of each of mass, say 1 kg, separated by distance of 1 meter in SI unit. Now what is the value of G? This is, as I said, the value, this is a universal constant. The value of G in SI unit is 6.67 into 10 to the power of minus 11 Newton meter squared, and then kg to the power of minus 2. So this is the value of G in SI unit. And we can also write the dimension of G. How to find out the dimension of G? Now we can write that G is equal to F into R squared divided by capital M into small m. So if you want to find out the dimension of G, what is the dimension of F? The dimension of F is M1 L1 T minus 2. What is the dimension of R? This is the distance. So this is L squared divided by, there are two m's, so we can write this as m to the power of 2. So the value of G will be, so this is 1 m here and m to the power of 2 here. So this will be m to the power of minus 1. And what will be L? How many L's are there? 2 and 1, 3. So L to the power of 3. M to the power of minus 1. So this is, again, let me tell you, this is M1 and this is M2. So there will be only 1 left. This 2 will go up. So this will be minus 2. Minus 2 plus 1 is minus 1. Again, L is 1 and this L2 here, so L3. And what will be the value of T? T will be equal to your minus 2, so T to the power of minus 2. So this is the dimension of gravitational constant. So after having known the value of G, the universal gravitational constant, now let us see what is known as the gravitational field. So next we'll discuss gravitational field. Now, as you know that we know what there is a cricket field, then there is football field, just like that there is gravitational field. That means suppose this is a body here, a body is having a mass m. Now this body is having field all around it, Now this if you bring another body of say mass m, and once you enter into this field, immediately then there will be a force of attraction between them. So when this body, small mass m, is outside the field, there is no force of attraction. But once it enters its field, immediately there is force of attraction. So what we can say, what is the definition of gravitational field then? The space in which a mass or a system of mass experiences a gravitational force of attraction in a gravitational field. Theoretically, this field around the mass extends up to infinity. So this distance of this gravitational field is around infinity. But in practice, it is limited up to small distance. So again, let me tell you what is gravitational field. Gravitational field is a space around a body in which another body having some mass will experience a gravitational force of attraction. So this body is, when it is outside the field, it will experience no force. But once it enters the field, it will immediately be attracted, and it will come and hit this body. That means there is a force of attraction. Now usually this gravitational field extends up to infinity, but in practice this distance between the two bodies are usually small. So this is known as gravitational field. Now let me explain you what is called the gravitational intensity. Now, what is gravitational intensity? Now, gravitational intensity means, the word intensity means strength, or the strength of the field. Now, how to find out the strength of the field? Now, we know the force of attraction between two bodies is equal to G, capital M, small m, divided by, say, this distance is r squared. Say this distance is now r. So, the square of the distance. So, F equals to G, capital M, small m, divided by r squared. Now, if we can write that small m is equal to 1 unit, then what we write? Intensity I now. No more F now. Let us write intensity I will be equal to G into capital M divided by r squared. Because your small m is equal to, small m becomes 1. So, I equals to how much? Gm divided by r squared. That means the force experienced by unit mass. This is unit mass. So force experienced by unit mass in a gravitational field is known as gravitational intensity. Or we can also write like this, that F from this equation, F by small m is equal to G into capital M divided by r squared. So so this is the same expression, Gm by r squared. So this is the same expression, Gm by r squared. This is also the same expression, Gm by r squared. So that is also known as intensity. So we can say the intensity is equal to force per unit mass, and it is given by Gm divided by r squared. So what will be the unit of intensity then? What will be the unit of intensity? SI unit. Now immediately you can find it from here. It will be newtons per kg. So newtons per kg will be the SI unit of gravitational intensity. So let me repeat again. Gravitational intensity is the strength of the gravitational field. Now, how to find out the strength of the gravitational field? The strength of the gravitational field is a force experienced by unit mass. So unit mass, so if you take unit mass, then m equals to 1. So I equals to this quantity. Or you can say gravitational intensity is force per unit mass. Force per unit mass, if you write from this expression, we get the same expression here, gm by r squared. So what is the SI unit of gravitational intensity? Gravitational intensity has a unit of newtons per kg. Now let us understand what is acceleration due to gravity. Now the force of attraction between the earth and any other body on it is termed as gravity. The body in this case is attracted towards the center of the earth. The acceleration produced by this force on the body is termed as acceleration due to gravity. Now let me explain you. Suppose this is the earth. Now this earth has a mass capital M. Now this is the earth and this is the center of the earth. Okay, this is the center of the earth. The earth has a radius capital R. Now if you have another body of small mass m, say, and it is above the surface of the earth, and the distance from the center of gravity is small r. The distance from the center of gravity is smaller. The force of gravity on the mass m at a distance from the center of the earth will be given by F is equal to G capital M small m divided by r squared. Now let me explain again. Suppose this is the radius of the earth is capital R. This is radius of the earth is capital R. The earth has a mass capital M, and the body, another small body having mass small m, it is at a distance small r from the center of the earth, then the force experienced by it is given by F equals to G capital M small m divided by r squared. Now according to Newton's law, according to Newton's second law, we can write F is equals to M, and instead of A we are writing G, because this will be the this acceleration will be now acceleration due to gravity. And what is this? This is the Newton's laws of gravitation. And what is this? This is from Newton's second law. Now if you see, or if you combine these two equations, what you get? The G capital M small m divided by r squared is equals to how much? mg. So this small m cancel, or we can write that your G is equal to gm divided by r squared. So this is the value of acceleration to gravity. Now if this body is placed on the surface of the earth, then your small r is equal to capital R. If small r is equal to capital R, then G equals to how much? Gm divided by capital R squared. So the acceleration with which a body falls towards the center of the earth is known as acceleration to gravity, and the acceleration to gravity is given by G equals to Gm divided by r squared. So let me repeat again. The force of attraction between the earth and any other body on it or near it is termed as gravity, and the acceleration with which the body falls towards the center of the earth is known as acceleration to gravity. Now the force of attraction between the earth and this body is given by this. This is from Newton's laws of gravitation, and from Newton's second law of gravitation, F equals to mg. And if you compare these two equations, we get G equals to Gm divided by r squared. But if the body is placed on the center of the earth or on the surface of the earth, then your small r equals to capital R. In that case, G equals to Gm divided by r squared. So this is the value of acceleration to gravity. Now you see, acceleration to gravity is independent of small m. This m is not there. So this Gm divided by r squared, it only depends upon G and m are constant for earth, and it only depends upon the distance from the center of the earth. So acceleration to gravity is independent of the mass of the body.